So we're going to get very up close and personal with some language data now. Computers are really complex electrical switches. They operate using binary, ones and zeros. And the way that we encode language data, there's a few systems that convert these ones and zeros into formats that we can use as text or as audio. So a bit is a 1 or a 0. It's a single bit of information. Bytes are sequences where there are 8 bits in a row. I've got a table here on the slide that shows how the decimal counting system can be converted into the binary counting system. So a decimal character 0 or the number 0 is represented in binary as a 0. The decimal 1 is represented as a 1. The decimal 2 is represented as a 1, 0. And these can be padded out with extra zeros on the left. So all computer data ends up as these binary symbols. In the early days, there are multiple alternative formats or tables that people used to convert the characters that they wanted to write into the binary codes. There are lots of different systems, and so we had a lot of conflict. This chart on the slide is the ASCII chart. This is one of the early systems that represented 128 characters, letters and numbers in the English writing system, as well as a few space codes and control characters like new line endings and delete sequences. So you can see in this chart that if I wanted to represent the letter A, I could use the binary 1000001. So this is the top orange square, and then joined together with the right orange sequence. It was a good system, but it only worked for English. Well, it barely worked for English, and it didn't work well for the rest of the world's languages. So there was no way using ASCII to encode Japanese or Chinese symbols or other writing systems. So the Unicode standard was developed. It supported this basic ASCII system plus a lot of more characters. Here we can see how Unicode represents bytes. And then this also shows the relationship of fonts to the Unicode. So a font is the graphical representation of a character. So the right-hand column, if we want the letter A, we can use the Unicode code point of 0041, which is a representation of the binary code in the left-hand column. So fonts are different ways of representing the characters. You can have a different shape font, but as long as that font points to that same Unicode key point, we know that it'll always represent a capital letter A. So we can swap the different fonts. We keep getting, we'll always have a capital A. The bottom row here shows that at some point we run out of binary numbers in a single byte, and so we need to use multiple bytes to represent a character. So the euro symbol was added later in the Unicode table, and so it needs multiple bytes to be represented. This image is a part of the Unicode table. There are many, many thousands of symbols in Unicode now. And this shows some of the Greek and the Cyrillic and Chinese characters. Unicode also carries the emojis that we're familiar with. and math symbols, many more. Now this is a representation here of the snowman. It's a great demonstration of what happens with fonts, in that when I was typing this into the Google Slides that were used to create these slide sheet, this snowman was a simple outline. It's got the same Unicode value and it points to the same binary. But here in this preview, I've got this cute graphic. So the graphical representation has changed, but underneath that, we've got the same Unicode data. Likewise with the coffee cup. Using the same Unicode, this coffee cup will look different on different systems, but it'll still be a coffee cup. So likewise with audio, encoding is important. This came up in the tutorial last week where different encoding, the WAV files, high resolution encodings, the MP3 files that some people were using a low resolution. WAV files are commonly used in language technologies because they are high fidelity, they carry a lot of information, they're high quality. They have larger file sizes, but people attempted to use MP3s because you can compress the audio, you can fit more MP3s on a portable player, but the compression removes information from the audio signal, which makes it less usable in developing language technologies. Just as a point there, if you do want to use some recording apps on your devices, Hokusai and ASR are two recorders that you can use on Android or iOS.